Hi, this is the observationist here. This is my premiere video. I'm going to be talking about climate change. We're going to have a series of videos about climate change. It's been something I've been looking at and studying and trying to figure out now for about 25 years. And I find it fascinating, and I think it has some importance about our future as a species on this planet. What you see behind me right now, that is the current CO2 level in our atmosphere. It's at a website that I recommend. It's called CO2.earth, CO2.earth, and you can see whatever the existing CO2 levels are any day you want. It's really handy. We're going to be talking about CO2. What it is and why it's important. First of all, CO2 is not a pollutant in the normal sense of the word. It's a process of life. We exhale it every time we exhale, and the plants do the reverse. They bring in the CO2, and then they put out oxygen, and which we then breathe. So we animals do the exact opposite of what the plants do. And that actually can be seen by how the CO2 levels vary throughout the year. There we go. Let me get my mouse. Okay, let's take a look at this. This is the way CO2 goes up and down every year. Okay, it goes up in the wintertime because we're exhaling. We're exhaling in the wintertime, and the plants are not doing anything, so the CO2 level rises. And then summertime happens, and the plants start growing. Now they're bringing in the CO2, and so they're using it up. So the CO2 levels in the atmosphere goes down. So it does that every year. Now, if you notice, this is showing what's going on from the year 2020 to 25, and how it's been going up at a very constant rate. And so this is very inexorable. Year after year, the CO2 levels are going up. It didn't used to do that. It used to be, throughout the entirety of the Holocene, from 11, 12,000 years ago to right the industrial age, CO2 levels were pretty rock steady, about 280 parts per million. Since the industrial age started, about 20 years ago now, the CO2 has gone up, as you saw, to 427 parts per million. So it's roughly gone up about 147 parts. Let's round it to 150 parts per million in 200 years. And that's where we're getting the global warming from. Now, if we look back further, we go back to the Scripps Observatory in Mauna Loa, then we look at from 1960 with this, when they started taking the records, till now. This is the annual fluctuation I just showed you up here. This is it going from 1960 to 2025. And if you notice, this slope started off about here, is now going up like that. So you see what's going on? CO2 is going up here about half a part per million per year. And now here we're going up about 3 parts per million per year. So remember I said it took us 200 years to go up 150? Well, now we're going up about 3 parts per million. Let's take a look at here. See this, if you look on this one here, okay, here we're showing July 24, 23, 22. And here you look, in these 2 years, it went up 7 points. So it went about 3.5 parts per million for these 2 years. So let's round it down to 3 parts per million. That means in 10 years, we'll go up 30 points, as opposed to the 200 years took us to go 150. So as you see, it's accelerating very fast. And that acceleration is very likely to accelerate. Now it's at 3 parts per million. In 1990, it was about 1 part per million. In 2000, it was about 1 part per million. And now it's at 3 parts per million. So in the year 2040 or 2050, maybe it'll be going up at 4 or 5 parts per million. Scary thought. So the global warming is going to be accelerating because we're accelerating the CO2 levels. Okay. Now, the one question is that, wait a minute, how do we know that CO2 levels and global warming are somehow connected? How do we know that? Well, besides having done laboratory experiments to show that ultraviolet rays goes through the atmosphere, but infrared rays do not, hence the global warming result. If we look at this is a graph. Now this is going from the present day is on the left to, let's say, 500 million years ago on the right. We see how sea levels had gone up and down during the past 500,000 years. At the same time, CO2 has been going up and down for the past 500,000 years. And I think just visually you can see that there's a strong correlation between them. Now, is it a 1-to-1 correlation? Nah, there are, like there's this little bit here. Why, here the sea level stays constant for a few thousand years, but for some reason the CO2 peak, spikes upward, but it doesn't have a concomitant increase in the sea level. Or you get something like this where the CO2 is relatively constant for 10 or 20,000 years, but the sea level goes up and down. So there's it's not a perfect 1-to-1 because there are many other things going on. One of the things that goes on is when volcanoes throw out what they call particulate matter, then what happens is that could actually have a cooling effect, despite the CO2. So it's there's other things going on. There could be shifts in the air currents, shifts in the ocean currents, and all things can affect how the ice behaves and how climate behaves. So it's a lot more complicated than just a simple metric. But we can tell by this that the CO2 vector is very, very powerful in determining sea levels. Okay? Now, we can go back. This is something, okay, let's look at this. This is something that, I don't know if you've ever seen this. This is showing CO2 levels for the past 500 million years, going all the way back to the Cambrian era. That was when basically life started on this planet in any meaningful form. Meanwhile, the average global temperature is shown by this blue line. And it goes up and down. And there's not as much of a correlation here, partly because we're not as certain about these numbers, especially when we get back to here. I've seen another graph where this black line showing the CO2 levels is shown as basically a widening bar with a widening area of range, or high and low range. And by the time it gets out here, it's really wide. They really are not fully certain exactly where it is. But we do know it was high back then. We just don't know how high. The other thing that I learned in my research is that the relationship of CO2 levels to the warming impact is not linear. It's logarithmic. So as CO2 levels get higher and higher, the actual impact of each additional level of CO2 becomes less and less. So 4,000 parts per million is not 10 times 400 parts per million. It may be double or triple. Okay? So anyway, So we have, by looking at these graphs, you can kind of see that it's fairly certain that there's a CO2 impact. And there's also impact from methane, CH4, which I'll talk about in another video, and how important that impact is. But I wanted to just show you this to show you how important the CO2 levels are, and how we are going up by 3.5 parts per million. Now, the thing that is important to understand is that at least from my point of view, I don't believe that we're the only ones throwing CO2 in the atmosphere right now. I think we were 60, 70, 80, 100 years ago. But now what's going on is the permafrost is melting, and we're actually getting some methane clathrates in the oceans bubbling up. But the permafrost is melting. That's beginning to throw a lot of that CO2 in the air. So the question is, back in 2000, when CO2 is going up by 1 part per million, and now it's going up by 3.5 parts per million, is humanity the sole cause of that added increase? Or is nature now throwing in its 2 cents into the equation? Is now nature throwing in 1 part per million, or 1.5 parts per million, or 2 parts per million into the equation? If that's the case, which I think it is, although I do not know how much, but I would expect maybe in the part of 1 part per million or in that neighborhood, that means that to a great extent, the CO2 levels in the atmosphere have been partially taken out of our hands. That means that even if we stopped producing all CO2 emissions right now, humanity just disappeared off the face of the earth right now, then the melting permafrost alone would add 1 part per million per year or so, and that would keep that ball rolling. So the Earth would still go into a very warm phase. Now, we'll be talking what those very warm phases mean in the next video. Anyway, hope this is of some use. Hope this is of some interest to you. There's going to be more. Thank you very much.